Hello, students. I was looking for the video to embed into the Nearpod for the quiz, and I can't find it. So we're going to make it now. This is the 207 quiz quadratic regression model help video. So in theory, you've already been in class and we've had some talking about what's going on here. So we'll just kind of jump right in. So in the first question, they're asking for a quadratic equation that fits the data in the table. You could calculate this by hand, but a quick, let's just look up a quick quadratic regression model formula. There it is. Okay, here's the matrix equation. Here's the summation equation. And then you kind of go through the data to try to figure out the line of the quadratic model of best fit. So this is what I wanted to show you. It is basically like you take the squares of the differences. We're not going to do that. So you don't have to worry about calculating this by hand, okay? So when you see this, you do want to use technology. It's really important that you use technology. So here's what we're going to do. We're going to zoom in, and that's one of the reasons I wanted the help video ready for you guys right now. You're going to take this data, Control C. So I highlighted it, Control Copy. Can you right click it? Copy. Cool. We're going to go to Desmos. What? We're going to hit Control V. That did not work. So let's do Control Z, undo, add a table. Control V. Nope, that still didn't work. Oh man. We're going to find the quadratic regression because I know I have one made. Here it is. Okay, let's see. Last year, open graph football kick. Nope. Quadratic regression. Yes, open graph. Okay, so this is just the blank quadratic regression, and I need to give this to you. Okay, and you need this table, and we built it by using this formula. We have a table. We're going to put in the table, and then this right here tells the calculator to do a line of a parabola of best fit. So we don't have to do it by hand. So let's pull this out. And I guess we can't copy paste. I thought we could copy paste. Why can't we copy paste? I copy pasted it once and it was so beautiful. It just took the whole table for me. I'm very frustrated right now because I was so excited to watch it just take it as a table. No, it didn't work. Oh well. Looks like we're doing it old school. We have to enter it by hand, and that's okay. So you have, this is what I do. I'm lazy. I can't tell you how lazy mathematicians are. We're always looking for a more efficient method. And how do we do it shorter? How do we do it quicker? Which is why we have a lot of these equations and functions and notation, which we were tired of writing it out in words. And we're like, oh, can I just like create a symbol to tell people what I mean and then make them learn it? Okay, but anyway, we're lazy. I'm going to just go down the x-axis right here. See these x values? I'm going to type them. -5, arrow down. -2, -1, 0, 3, 4, 6. We're done. I'm going to go back over. I'm going to go back up. So 33, 33, up, 15, up, 9, up, 3, up, 5, up, 9, 33. Okay, so now we can check it, and it's a nice little check too, because if you did it wrong, you won't finish right back at the top. So that's what I do. I just click over here, I do all of the x values, arrow down, I use the arrow key over, and then I go back up, and then I check it. Cool. So now we're getting this crazy regression model. So the black lines are the actual data points. Let me turn off this red graph for a second. We're just going to turn it off. That's our actual points, right? We have 1, 2, 3, 4, 5, 6. Okay, we have to get up to like to 33. There they are. 1, 2, 3, 4, 5, 6, 7. Okay, 7 points. There they are. So what this is doing is it's doing all of the math work for us. All those summations, and you square them and you find the difference, and then you figure out these coefficients, boom, A, B, and C, the coefficients of the regression model. They'll tell you right here, we have A, B, B, C, C for our regression model. Okay, that's kind of a nice looking parabola. So we'll turn it on, and look, it does pretty good catching all the points. There's some error like there. We can talk about residuals and leftovers of points, but wow, it's like almost spot on right here. Boop, 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 boop. So whatever these data points are that we were given, what it could be projectile motion, right? It could be height and time. It could be distance and time. It could be all sorts of things. So whatever it is that's modeled, it's going to be a parabola that will make its best prediction. So that's what a quadratic regression model is. We're given some data. It may not be perfect, but it's better than a line, and it's better than, say, a exponential, like e to the x, right? Because we'd miss this whole half of the data. And it's better than our rational functions, right? Because we have these different things that we've been talking about. They're all used to model real situations. Okay, they're all used to model something, and we need to figure out which one makes the most sense when we're given real data, real points, real information. Okay, not just equations. Right now you're just learning about the equations and whatnot. Okay, let me get out of here. Let me turn this stuff back on. I'll save this for you guys, and we're going to keep using this, and you will have this link. You will have this link so you can do your quiz easily. Okay. There we go. So how do we figure out this? I need that back, actually. Perfect. We need this back. Pull you out. Remember I talked to you about the equation down here. So how did we figure that out? We'll take a look. A is 1. We don't write 1. It's invisible. Invisible, invisible, invisible. Not that one. That's a negative. B is -1. So we have x squared minus 1, minus 1, minus 1. So it could be this one or this one. And then C is plus C, so plus 3. It has to be this one and not that one. This is standard form of a quadratic equation, where we have A is the coefficient of the squared term, the quadratic term. B is the coefficient of the linear term, just the x term. And C is the constant term. In this case, it's 3, so plus 3. Okay, so it's written all with positives. So if it's a negative, it'd be written with a subtraction. Think about that. Cool. Question 1. We're going to go on to question 2. Using a graphing calculator or other technology to answer this question? Well, Desmos is a graphing calculator and other technology. Again, take a look. So all of these numbers are very similar, and it's a hot mess. So take some time to think about it. Y hat, that's what we call it. Y hat is what we call Y hat the regression line, or the regression equation, because it's not a line. So this will be the coefficient of the x squared term. This will be for the linear term, and then there's the constant term. These are a bit messier. So let's go see what our calculator spits out. Oh, will this make it? It won't make it, will it? I don't know why I'm hoping. Oh, wait, what if I do this? Nope, maybe. Hold on, let me try. I told you, I'm super lazy, so I want it to work. It may not work, but it might work. I'm going to highlight all of this. Ugh. Useless. Oh, it did it. It did it down here. But now I want you to do it up there. I just need to change the subscript. Why do I need to change the subscript? Okay, so that would work. Let's make it a line that touches. Do lines. Okay, so there's our little, okay, so see, it's all, we made them connect. Ooh, that might be better like with an absolute value, but I don't know. You guys can think about that later. Let me check our points to make sure it did it correctly. 15, 423, 17. I don't know why it did it and didn't do it the last 2 times, so you might have to type them. But like I said, I am lazy. I don't want to type them. What I had to do though, technology, 21st century skills, I had to adjust this. Things are going to go wrong. Play with it. This has to match. Remember, we've talked about formulas. They've got to match. So this says x sub 1. This was x sub 2. If I put x sub 2, it's not going to tell the computer the right thing. See, it's like, oh, we need inputs. So let me go back and change it to 1. We should be good to go. 8. There we go. I got rid of those. So I just went in there and deleted them because I messed them up. All right, cool. So now how do we make this useful to us to figure it out? So I'm pulling out the window. I'm going to come down here and I'm going to say A is 2.608. If I have to round, I'd round to the ones place, right? Notice you can immediately kind of eliminate these two because C plus C, is the 1,568.06 thousand, 6,000s. And that's okay, right? We know it's one of these. It's close enough. So we know it's one of these two, so you can eliminate this one. So then you just need to scroll over. Let's take a look at B. Well, B is negative. So we know we need a subtraction. Boom, we found it. And now we can check A. A, the coefficient of the quadratic term, the coefficient of the x squared term, basically the number part in front of the x with the little 2. It's like in very basic, just what do I see terms, because a lot of math seems scary, but it's just our vocabulary. The coefficient of this quadratic term is 2 and 608 100,000, 10,000ths. That's the 10,000ths place. Wait, no. Tens, 100,000ths, 608 thousandths. Okay, anyway, that's question 2. What's going on here? Again, we have some sort of information. They gave us data. We either measured the data, we took the measurements ourselves, we figured this out, and we're like, ooh, how can I predict where this is going to go next or what this is going to do next? And we used a model. We used some technology, and we made a guess. Question 3, same thing. What is the quadratic regression equation for this data? Nope. Do you think it'll copy paste again, guys? What do you think? Let's try it. I'm going to zoom back out. I need this to copy paste because I am lazy. We're going to highlight just the number part. Try. Okay. Control copy. Control V. Cool. It worked. I don't know why it's working. So I'm going to close out of this one. I'm going to change this to the subscript of 1, or you could do this. You could change this to the subscript of 2. Oh yeah, we need that to be y2. Everything needs to be the same subscript, right? Because x2, y2, otherwise y1, it's like, what are you talking about? Ooh, fancy. That's very fancy. Let's zoom out and see what's going on. All right, well, notice our values are all over here and there's no points over there. We'll talk about trying to decide on a model, but I bet we could figure out a different model. Wow, that is like dead on though. They are exactly on this parabola. So, oof. Yeah, I don't know. This is exactly a quadratic model. They're exactly on this. That is crazy. So, anyway, that's our point. So this model, what I was thinking is maybe a different type of equation, but oof, I would probably just stick with the parabola quadratic equation to match it. So what did we do here? We copy pasted our values. Again, I don't know what these numbers represent. You can make it up. Nothing comes to mind right now. We can hold down this to make it a line, and we can turn this off to see, okay, it looks kind of like a curve. Man, it's really nice. It's very close. So for me, when I see that, it's nice to have a very good model. Everything around you is using predictive models. All of your technology is trying to predict, possibly control, your behavior. Everything, your phone, your TV, your computer, anything that has technology is tracking data and constantly making changes and tweaks so they can make the next prediction and make it more accurate, okay? This is just one numerical example that you get to play with. But as you leave math class, you would still have some sort of program like this, some sort of data you'll put in there, and then you're going to need to put in the parameters, like what's happening to it. You need to put in the data points and tell it what to do. You're just practicing a version of that here in Algebra 2. When you have a career, if maybe that's kind of interesting to you, you're going to be doing the same thing just now for your job, and yeah, you'll be getting paid. But right now, this is just the little foundations, okay? There'll be a residual plot we'll talk about. Ooh, interesting. Okay, but now for our purpose, we need to know the equation. So let's pull this out. That's what I would do. Hey, pull it out. Come down here. I would zoom in, and I would know, all right, I'm looking for A, 1.22 round, so to 5. B is negative 87, or just round right up to 8. You see that? 9999. No matter where you round, it's going to round all the way up to 8. Boop, boop. It's like an overflow. And then this one, you see it rounded to 8. Ours has 3 decimal places. That's okay. That's okay. They're the same number. They're close enough. 1697. 3.76. Ours is 3.8, but if this is a 6, you would round to 8. So there you go. There you have it. That's how you find it. Whether it copy pastes for you or you just want to sit there and type it, it doesn't really matter, but that's the skills you're going to need to do. I don't know if you heard that or not in the background. All right, here we go. Ooh, now we're going to use it. So here is the equation. With those numbers, it models the amount of sugar in pounds per square foot produced, where X is the amount of fertilizer in pounds per square foot used. Notice how the units need to match. Think about it. Do they need to match? They are matching, so that's interesting. What is the best approximate for the amount of sugar produced when 3 pounds per square foot of fertilizer is used? What should we do here? Like basic math, I have a y equals, they're giving me a number. Oh, it is off. My sound is off. Okay. I want to just plug that in. That's a very common thing. That's messy. So let's use the calculator. It's built in right here. You can always use Desmos Scientific. It's a little bit easier and nicer to write when you have Desmos Scientific, but we'll go ahead and use the one that's built in so you guys can see how to use it. Okay, so we're gonna have negative, you have to use this symbol if you're gonna do that negative first, 0.065, parenthesis, 3, close parenthesis, squared, and we're gonna have plus 6.875 times 3 plus, and this follows order of operation. So it's going to do the squaring, then the multiplying, and then the adding. One of the reasons we talk about order of operations is because of calculators. And yeah, so we should be good to go. Equals 6,220 pounds-ish. Let's see. What is the best approximate? There you go. 6,220 pounds per square foot for the approximate amount of sugar produced when 3 pounds per square foot is used. So that's pretty cool there. They finally told us a story of maybe a way that this quadratic regression model can be useful. This is true. Companies use predictive models all of the time, and they're going to want you to optimize it for them. They're going to want you to say, like, hey, this is what the math is saying. Let's go do it. They do the math and the predictions before they build things. They do cost analysis. It's just never going to leave the professional world. or your adult life, you'll want to just be comfortable coming up and talking about it. They're just numbers. Just try things, see if it makes sense, and then go from there. This equation approximates the average sales price of a house in thousands of dollars for years T since 2010. What is the best estimate for the price of the house in the year 2020? Okay, so now we have some critical thinking to do here. You'll see this on things like Zillow, Realtor.com, Redfin. I don't know the other ones that are out there. There's so many. But they do use these math models. You'll see graphs out there, and they'll kind of tell you their Zestimate for Zillow or whatever for your house value. And they're using some sort of mathematical model. I'm pretty sure it has more inputs than this, but then they break it down to an equation, and boom, the computer does the rest. It probably automatically updates as it gets more information. So let's just use the calculator again. We're going to think about this critically, though, because they don't give us the exact stuff we need to do. We're given the equation, average sales price of a house since 2010. What's the best estimate for a house in 2020? What do we use? What's going on? T is years since 2010. P is the price, so the output is going to be our best estimate. So our input is the time, but it's time since 2010. So up to 2020 is 10 years. So we're going to put in 10. Hopefully you had some time to think about that, but it's a video. So if ever you want to try to solve these yourself, pause it. Be like, oh, I want to think about it. And try the thinking, okay? 1.7 parentheses 10 close parentheses squared plus 18 and 75 hundredths. You can put parentheses. See, it automatically put the multiplication because it implies multiplication. The calculator is programmed that way. Plus 175. Just checking it. Looks good. Okay, so $532.50. Approximate, right? No. In thousands of dollars. So let's times this by 1,000. So they're saying it's about $532,500. So a little over $500,000 homes. That's the best estimate for the price. Oh, okay. So they even rounded up again. They rounded up to 533,000. There you go. That is how quadratic regression models are used, how you make them. You're going to use technology. You really won't do it by hand. It's a lot of tedious calculations where we can make mistakes in the adding, subtracting, multiplying, dividing part, and then our model won't be as accurate as these computers that when they use an algorithm, they're more accurate because they're going to strictly follow the steps repeatedly. Now, AI isn't using an algorithm to do math. It's doing math like you and I, which is why it's not 100% accurate, okay? So AI is very different than a computer algorithm. The computer algorithm follows the exact same steps as you and I, but because it's a computer and it's restricted, it's required to use the certain pieces, it's not going to make a mistake unless there's some sort of coding error, which happens. So always use your brain, right? This does not do the thinking for you. Even AI doesn't do the thinking for you. Somebody did the thinking for it, and then it's that person's thinking that's kind of modeling the AI, which is why it's still going to make mistakes completing math. Okay, hope this helps. I think it's very interesting. For now, just try it. Use Desmos, use your calculator. Think about what would I want to predict? Okay, what would you want to predict? What would you like to have a predictive model of that you could just plug something in and be like, oh, this is my prediction.